Hello. Today we're going to talk about inverse functions. So there are two ways we can solve for inverse functions. The first of which is algebraically. So what we have to do is take a function, for example, f of x equals sine of x, and we interchange the x and y values. In this case, if we do that and we simplify, we get f of x equals arc sine of x. However, there's an easier, more awesome, and more fun way to do it through graphing. And there are 4 steps to this. The first of which is drawing the original function. So we take f of x equals sine of x and we put it on a graph. We draw it. It's the red line here. Second, we take the line f of x equals x or y equals x and put it on the graph. It's this dotted black line over here. Third, we take the original function and we reflect it about the y equals x line. So it becomes this blue line right here, which is our inverse. However, we know that a function is only defined when it only has one y value per x value, when it passes the vertical line test. So what we have to do is restrict the domain such that there's only one y value per x value. So we take this reflection and we just erase the parts that make it not pass the vertical line test until we have a defined inverse function. I hope this makes sense. If this was too hard for you, it probably was because it's crazy. We have an easier example for you with the function f of x equals x squared. This is our common parabola. So what we have here is the parabola drawn in red, which is step 1. Then step 2, remember, draw the y equals x or f of x equals x line, the dotted line here. Then we reflect the original function about this line. We get the blue line here, the blue parabola. But then we have to restrict the domain because of the vertical line test, since it doesn't pass it right now. And the problem will most likely give you where to restrict it. In this case, we picked y is greater than 0, and so we just erase this, and we have a defined inverse function of f of x equals x squared.